Welcome to today's Partner Web Conference, Fast Track Dynamics 365 for Finance and Operations, Enterprise Edition, TechTalk. Today's topic, integration frameworks within Dynamics 365 for Finance and Operations. Presenting for us today from Microsoft, we have Praveen, who is a solution architect. Okay, Praveen, the floor is all yours.
Thank you, Leslie. Welcome, everyone. I see that majority of you have not attended this Tech Talk before, so I'll keep that in mind while I go through the content. I'm going to share my screen now. Leslie, are you able to see my screen?
It is still loading for me. Here it comes. Gotcha.
Okay, wonderful. Thank you. So we are going to discuss about frameworks within Dynamics 365 for finance and operations. I know when we talk about an integration landscape, there is a lot more moving parts into the mix. There are things like monitoring, there are things like orchestration, and a whole bunch of other stuff. But today, what I thought we could do is concentrate on one portion of this. In the subsequent iteration, which is happening in 2 days, on the Thursday session, we would basically be talking about the rest of the integration pipeline. So today, what we are going to concentrate about is going to be around Dynamics 365 for finance and operations. What are all the frameworks that the platform provides? And how does Dynamics 365 for finance and operations work as either a producer or a consumer of data and events, right? We'll also talk a little bit about how can we enhance the platform that is already out there, out of the box, by adding certain capabilities so that it can participate in much richer integration orchestration patterns, right? So the second iteration of this talk, which is like the part 2 of this talk, which would be held on Thursday, that's where we would cover about the rest of the orchestration in the context of Dynamics 365, right? And that's where we will cover things like EDI. That's where we'll cover things like monitoring, alerting, high availability, best practices, and stuff like that. So what is going to be today's agenda? So today's agenda, we are going to start with a very high overview of the integration platform that Dynamics 365 provides out of the box. Once we go through that and understand what we have out of the box, then we are going to go through each one of these feature areas, if you would, and see how we could utilize Dynamics 365 in enabling these scenarios that I have mentioned. I know authentication has been an area that many people sometimes struggle with because it's newer when someone is trying to integrate utilizing an Azure Active Directory OAuth type-based authentication mechanism. So we'll cover a little bit around how that is done. Then we'll look into synchronous call mechanisms, the tool sets that are available, the frameworks that are available, so that we can understand which one of the frameworks would work best in which scenario. Then we'll talk a little bit about the batched data APIs. So these are APIs for asynchronous large volume import and export of data. Then we'll switch gears into enhancing the platform that we have using triggers and piggybacking on triggers, how to enable webhooks, basically to expose endpoints and be able to receive callbacks, right? So that's the framework we'll talk about. And then we'll finish off with how eggs can make external third-party calls. And we'll talk very briefly about the data warehouse integration and how that is done. Right? And finally, if we have time, we'll go through question and answers. If we run out of time, I would stick around and I'll reply by messages, any questions that you have logged onto the screen. So for the integration platform itself, we have the Azure SQL database, which is at the lower IAS stack. As you know, Dynamics 365 is a SaaS application. So we do not expose this database or access to this database directly. So the only things that are exposed outside are basically endpoints that you see on top. Another thing that has significantly changed for people who are moving from Dynamics, so from AX 2012 to Dynamics 365, is that in 2012 there used to be a multitude of frameworks around AIF. There used to be one called Business Connector. There used to be a DIXF, which came late in the game, and custom services. And the problem with having one too many frameworks is that there would be lack of reusability in the investments that you make. So when I make an investment in my AIF framework, that investment cannot be reused by another framework. So to avoid that, in Dynamics 365 for finance and operations, there was a very thought out view that we'll try to make one particular framework, our underlying framework, as the key place where we would have most of our business logic and schemas being defined. And once that is being done, that same framework can be utilized in multitude of scenarios, thereby encouraging reusability. So that framework in finance and operations is the data entity. So the data entity by itself, I'll explain a little bit more about what a data entity is. The data entity itself is basically, think of that as a view, an updatable view of tables with some business logic tied to it, right? So once we have the data entity defined, the data entity can be exposed through an OData stack, as well as the same data entity gets exposed through a data import-export framework. The OData stack is a REST-based service through which people can make calls into these data entities. You can also define actions on these data entities. For example, if you have a data entity called sales order, you can have an action on it called confirm or an action on it called post. So it could be used for both data as well as process integrations. The same data entity gets reused or consumed through the data import-export framework, which is our asynchronous high-volume interface. So if you have thousands of records that you want to bring in bulk, then the framework that you would end up using is the data import-export framework. We know that there are certain scenarios where, although a smaller subset, it may not necessarily fit well within the paradigm of a data entity, i.e. having a structured data. In those type of scenarios, as well as to enable SOAP-based integrations, we also have the framework, which we used to call as the custom services, still available in Dynamics 365 for finance and operations. The way that works is you basically write an X++ class and certain public methods which accept some parameters, and you can decorate them with certain attributes. By doing so, we automatically expose those as endpoints in both SOAP stack as well as a REST-based stack. So the idea basically is any integrations that we build is built on top of these endpoints. So it's key for us to understand what is this data entity is, because that is going to be the framework that exposes data along with business logic for a vast majority of our integration scenarios. So as I said, the data entity was an idea which was produced to result in two results, basically. One was we wanted a data entity to represent a business object, a business concept, and abstract away complexities of the internal implementation of AX. So, and number two was we wanted to utilize this data entity as this one centralized framework where when someone makes an investment and writes their business logic and code, it could be reused for a variety of scenarios. And here I have called out some of the simpler scenarios where the data entity is being reused. So as I said, a data entity is basically a business concept represented as a flat file format. And the intention is that it abstracts away the complexities of an internal implementation. When someone talks about a customer entity, the end user, the functional end user, should be able to look at that entity, look through the columns, and make business sense out of what that entity represents. And the person should not have to deal with the internal implementation on how it is implemented within AX. The underlying complexity could be that we represent it for normalized for reasons to normalize data. We might end up storing them in way too many tables. There might be some additional business logic and checks and a whole bunch of other things that happens behind the scenes. We do not want to expose that same complexity to the outside world. And this data entity is the concept that abstracts away from that. So once we have the data entity, now we are going to talk about the different features sets that are within the system. And as we progress through that feature sets, we'll talk once again about how data entity plays a key role in exposing those scenarios. The first thing that I want to talk about is authentication. So any API call, any integration API call that you make into AX needs to have authorization based on OAuth 2.0 flows. The commonly seen scenarios, especially for a middleware type integration or an application to application type integration, is these flows over here. So the service to service integration is very common, and there are two flavors of implementing it. There is a shared secret way of doing it, and as well as you can use a certificate to basically do authentication against Azure Active Directory. Same wise, there are certain scenarios where I have seen customers utilize the authorization grant flow to basically do authentication for integration as well. So let's go through a simple demo on how to basically enable the service to service authentication calls, and I'll show you both these flavors, and then we'll continue further. So I'm gonna share my screen. Having a little tough time of showing it up there, but kindly bear with me.
We see Dynamics 365 right now.
Awesome. That's basically what I want to see. Okay.
Okay.
Thank you. So the first thing that we do is we would need to log on to Azure Active Directory in the same tenant as the Dynamics 365 is deployed. And that is very key to start with. You will not be able to authenticate cross-tenant. So if Dynamics 365 was installed in a different tenant, and as an end user, you are part of a different tenant, you will not be able to cross-authenticate by registering for an application in a different tenant. So that's the first step of validation that you have to go through to make sure that the tenant in which the AX is installed is the same tenant in which you are basically setting this thing up. The next thing that you would have to do is go into Azure Active Directory. So I have already opened it up here, but if you go to services and search for Active Directory, this is going to load this thing for you. Many of you might need an elevated permission to set this thing up. So that's another thing to watch out for. If you suspect that you don't have enough permissions to set this thing up, you might have to work with one of your tenant admins to get this thing going. So the next place that I go to is app registrations. And the OAuth flows are tied around very specific scenarios. And I'm not going to go into the detailed on how to select these flows. I'm just going to show you a couple of these flows to get you started. There is a very good documentation on docs.microsoft.com from the Azure Active Directory team who have explained in what type of scenarios, what type of OAuth flow should one select. So I would let you to refer to that. I'll also send you a link to that at the end of this meeting, so you all can take a look at that. So the next thing that we do over here is I would register for a new application. I'm going to do a client secret authentication here, authorization here. So I'm going to give a name, TechTalk 01. I'm going to leave it as web app, and since it's going to be client client credentials flow, I can basically give any name that I want here. I just need to make sure that this is valid HTTP string. I'm going to click create. So once the creation process is done, the only two other steps that is pending is number one, you would copy the client ID, and number two, you will generate a secret key for this application. I have an application, okay, that got created. So this application ID becomes key for me. This application ID is going to be the client ID. And the next step that I need to do is go here to a key and generate a key, basically. I say TechTalk 01. I'm going to select the duration and I'm going to save here. On save, this is going to generate a secret value. I need to save the secret value before I close this because this secret value will never be visible on the UI again. The next thing that we do is copy this application ID. Since I'm doing a client credentials flow, this particular flow needs an access control list to be maintained by the end resource. So the end resource being AX, there is a place here where if I go to the hamburger button, go down to system administration, there's a place that says Azure Active Directory Applications. I need to basically come here and add my client ID, provide a name, and assign what is the context of security that I need to impose when I get a connection from this particular client. Right? I'm going to select admin in this case. So once I have done that, now I'll be able to go back to my application. So in this case, I'm going to showcase this using Postman. So here I already have saved my grant type as client credentials. There's a tenant. The client ID and secret is something that I generated using a different client that I registered. So that's what gets filled up. And you can see the HTTP endpoint to which I post this message basically looks like this. And here is where your actual tenant ID should get filled in. And your body in form data form would basically need to have these information. The resource is basically your Dynamics 365 endpoint without the slash at the end of it, and that is key. So it's basically this portion of your URL without the slash at the end. So once that I have done that, if I do a send, you'll actually see that I'm able to get a token back. And this is the token that I need to tag with every request that I make to talk to AX. And as long as I have this token with me, I'll be able to successfully access AX and interact with it. So that's basically the client credentials authentication flow using the secret key. I'll basically demonstrate the same thing using a certificate. We have seen customers who have requested that they want to utilize a certificate installed on a machine, and the application that runs on that machine should be able to access that certificate and be able to successfully talk to AX. If such certificate doesn't exist on a given machine, then the person will not be able to talk to the application, will not be able to talk to AX. And the process for doing that is, so here is a simple example where this is basically a PowerShell script. I'll share these things in the GitHub page. So basically, we are creating a self-signed certificate with a name called Postman Cert01. And this is currently installed in my user under my current user under my, and it basically generates a key credential at the end of it, and it outputs that into this key credentials. So the step to follow, instead of using the client secret, but rather to use a certificate, is basically take this information, the output of whatever is within this particular file, and you have to go to the application page here, click on manifest, and fill this portion with whatever that file's output is, and save it basically. Right? So I have already done that. And I'm basically going to show you how this particular approach works. So if I go to the authorization helper, I have two methods here. The first method is basically utilizing the client ID and the client secret. The second method over here utilizes client certificate, and that's what I'm going to utilize to do this authentication. And most of this code is standard. This is available in many helpers out there. The key thing to note is to say what is the name of the certificate that needs to be utilized and what is the client ID using which one needs to talk to AX. And this client ID should match the client ID that was registered within AX as well, which is basically over here. Right? So once you have done that, let me just show you a simple read legal entity example, which is in this particular flow is utilizing the certificate to do its authentication. So you can see that we are able to read all the legal entities within my demo data within AX. Right? And it is utilizing the client certificate for this purpose. So there are some scenarios where people have requested an authorization code grant flow to be utilized. And the scenarios are basically they wanted an end user to basically consent to utilizing an application, but the actual token they wanted to save it in memory by a middleware somewhere. And the tokens can be active for about 90 days with using refresh tokens. And the idea was that they would come back periodically and provide this authorization, and the token will never be saved onto a disk. And the token would always remain in memory. And if the application for whatever reason shuts down or the machine gets restarted, then that end user needs to be involved in order to basically give this permission. So the way to do that is, once again, I'm going to showcase it using Postman. So these are basically the different information that needs to be filled in. So this callback URL is very specific to Postman. In the case, in real world scenario, this callback would be the callback of the application, which is going to host that token and the refresh token basically. And here you can actually see that we are mentioning we need to do authorization against login.windows.net and we're providing the resource, and the resource is actually our endpoint. And here we only mention what our client ID is, and I'm going to say request token. And this is going to provide me a login screen. I may not be able to authorize over here because I don't have admin access to Microsoft's Active Directory, but I'll at least show you what it looks like. So after the authentication happens successfully, you will actually see a place where the consent is requested from you. Since I don't have access to this Active Directory admin access, I may not be able to do that. But if I were, it will basically ask me a permission to say accept or cancel. And if I accept, the token will be issued and the flow will continue. So that's essentially the popular two flows that we have seen utilized by most of our customers. There are other scenarios where people would want to do authentication from a mobile phone and stuff like that. Since this talk is purely around integration, I'm not going into detail into those. Okay. The next topic that we want to talk about is about making synchronous calls into AX. So as I said, there are two stacks through which someone can make calls into AX. The first stack is basically an OData stack. The OData stack sits on top of the data entities, and the data entity basically sits on top of a queryable interface to the Azure database itself. So in a way, the way I introduce OData to many of my customers is that I call it SQL for the web. It is REST-based. It is stateless. So there is no connections that is held. So it's very efficient when it comes to web-based communications. And also the normal things that you would expect to do in SQL, like doing CRUD operations, insert, update, delete, your query operations, doing joins, aggregates, all of those are possible using this OData format. For process integrations, OData actions can also be added to your data entities. The way you do it is you would go into your data entity, in the data entity, you can add methods. And for those methods which has a special attribute that says it's an OData action, we basically expose that as an OData action for end user to basically call into. And the OData stack basically supports two messaging formats. One is JSON, the other is XML. Most people that I have seen prefer JSON. The reason it gives you better compressibility, it is saves on message payload sizes. So that's what most people utilize. And there are popular tools and libraries on manipulating JSON. Although there are some customers who would like to use XML, those are primarily scenarios where they want to do XSLT transformations, either for EDI or things of that nature. So that is one way by which someone can make a synchronous call into AX. The other approach is basically a custom service. The custom service, as I said, is an X++ class that someone can write and put some special attributes on the methods and the class to basically expose it as an integration endpoint. So I'm just going to walk you through a simple example of an OData call here. So I'm going to look at some simple query examples. So the actual endpoint itself, let me go back to programs. So I have defined this AAD resource as my endpoint, which is basically this. And the end of that AAD endpoint, you can basically add /data. That is basically the root node for your OData, basically. So once I have done that, so I have my resource name /data, and the end of it, if I say /vendors, and I make a request, and here my header actually has the bearer token. So this is a valid request. You can actually see the JSON results that I'm getting. Right? So this is basically giving me the list of all vendors in the system. And you can see all the different columns associated with this data entity is being displayed over here. So the same thing can be done using a C# library. And I'm using a library called OData client code generator, which will basically give me a strongly typed class against which that I can operate. Since we have gone through in detail about how to set this thing up in one of our previous talks, I'm going to skip that particular portion and just showcase the actual usage itself. Someone who wants to utilize it and install it can go back to the previous tech talk, which is on YouTube. Look at that and follow that scenario. So some of the simple query examples that I have written over here is basically when I do this is the client .legal entities. If I enumerate over it, it will basically read all the legal entities for me. You can also do things like, okay, I want to get a total count of all my vendors. The way you do it is vendors.include total count. These are basically API options that are available. So these are basically query options where I can do get top records of all my vendors. So you can see that I'm adding a parameter that says top and I'm setting a value called 10. So there are well-defined patterns on how this is done. And these scenarios are well documented in Okay, I don't seem to have that open on my computer now. At the end of this talk, I'll paste the link for you. So there is an OData.org website. And if you go over here, you can actually see that these scenarios are very well documented. So the one that we tried was /people, like /vendors, basically. Here they are using people. If I want to look up a people by a specific key, and this is how I would provide it, and so on and so forth. There's like good amount of information on how to do query through REST-based APIs. So, and I also have an example over here that basically does a simple CRUD for me. This is gonna read an entity, update an entity, and finally delete that entity, right? And you can see that all of these are not can be written using simple 2 or 3 lines of code per operation. And these examples are uploaded on GitHub's integration page. So if I were to walk through this scenario really quick, can actually see that the asset was actually created, it was read, and finally, once it was deleted, no records is actually found over here, right? Because it was actually deleted. So this is how you can do CRUD operations on data entities. So if you have a sales order that you bring into the system, this is a similar approach that you would take here. So going back to the slides, I basically want to talk about three different things that people would do whenever they make a synchronous call. One is people would want to make a transactional, set up a transactional boundary in order to ensure atomicity in the synchronous calls that they make. And OData has this as its native feature set. There is a thing called chain sets within OData. And using chain sets, one will be able to make the OData calls that we make into a single atomic transaction. So I have a simple example with me here. Once again, all of these examples are available on our GitHub page. I'll share you that link as well. So here I'm creating a single sales order header, and I'm having a sales order line. And the sales order line has all the data correctly filled in. So this sales order line, if I run it, would actually succeed. So I'm going to go here. I'm going to say, I'm going to submit the sales order within a single chain set, and I'm going to run and see how it works. So that has been saved. So if I were to go to AX, and if I go to all sales orders, the number that I used was 100,008. You can actually see the header was created and the line was created. So I'm going to do the same thing, but I'm going to basically insert an error. I'm going to update this to 9, and I'm going to insert an error over here called ABC, which is incorrect shipping site. So my header should succeed, my line would fail. Since I'm submitting it as a single atomic transaction, both the header and the line would get rolled back. That's what I'm going to show you now. So you can see that the sales order did not save correctly. That is expected. And I'm going to close this here. And if I do a refresh, we'll actually see that there is no 100,009 record at all because it was completely rolled back. On the other hand, if I remove this option and if I submit the same change, you'll actually see that it failed. But if I go into AX, I'll actually see the header being created and the line actually failed out, right? So using a chain set is a way to ensure that we don't leave transactions that are not quite complete when we are bringing through integrations. So that is basically how you would do transactional boundaries in the OData stack. Custom services, since it is an X++, Dynamics 365 provides you a transactional framework, and that's what you will utilize to basically set transaction boundaries. The next thing with synchronous calls is whenever you're doing exception handling, the calling application should be able to handle the exceptions, and that's the nature of any synchronous calls. Some customers have scenarios where they want to throttle and log calls being made to AX. In those scenarios, they can use Azure API management. These are for scenarios where you are letting an external customer call into your API and you are not quite sure whether that person would behave within their quota, like would call within their quota or not, and you don't want that either due to an incorrect logging or a misbehaving application to put load on your application, your Dynamics 365 application, and bring down your system. And using Azure API management, you will be able to throttle as well as log traffic that comes into AX even through synchronous calls. The next thing that we want to talk about is basically around the batched data APIs. The batched data APIs provide you an ability to bring data in bulk into the system and process it within the system. So if you have large amounts of data that you want to bring in, can be done using this framework, and it is done purely in an asynchronous fashion. And there are two type of frameworks within this. One is what we call as the recurring integration API. The other one is what we call as the package API. The key differences between these two is the recurring integration API, the scheduling of this import is controlled within Dynamics 365. If you want the scheduling to be held outside of Dynamics 365, or you want the scheduling to happen on demand, meaning whenever I get this file, I want it to immediately import, versus it's okay for someone to send me this file, but I would choose that at every day at 7 o'clock in the evening, that's when my store's closed, that's when I'm going to do an import, right? Those are the type of decision-making scenarios that will help you decide between one of these two APIs. The recurring integration supports both single files, as well as data packages. The data management API only supports data packages. If you want XSLT transformation, only recurring integration supports. Another key difference is the on-demand data package API basically provides you direct blob access for you to upload and download files. So you don't run into any sort of file limitations in how you upload the file and download a file. On the other hand, the recurring integrations API go through an MQDQ API, and there is a 256 MB file limitation while using that API. So since the on-demand package API is the relatively newly released one, I'll just go through a simple flow on how this asynchronous flow happens. So here we start with the middleware. The middleware first makes a call to AX. The web client here is the AX web client. It makes a call to the AX to get a writable URL. The web client returns a blob ID and a blob URL. The blob URL actually has a shared access token, which is valid for a short period of time, using which someone can upload a file to Azure Blob Storage. So that's the next step that the middleware does. The next thing that the middleware does is once the file has been uploaded, it basically makes a call to the web service and provides a blob URL where the file is saved in order for AX to start processing that file. So the moment this call is made, AX kicks off a batch service process to start processing this file, and the process keeps running. Now the middleware can do a polling pattern to keep checking whether AX, that particular file that was submitted, has been successfully executed or not. So here there is an API that's called gets execution summary status, which returns an executing method. Once the file has been executed, it will either say succeed or partially succeed or completely failed, right? So those are some of the options here. The same can be done with the export as well. The first thing that happens is the middleware initiates an export and waits for that export to complete by checking on the status. Once the export is completed, you can ask for a URL from where you can download it. Once you get the URL, you can directly download it from the blob storage, and that's the flow. So I'm going to now talk about two new ways by which you can enhance the framework, out-of-box framework that is provided with Dynamics 365 in order to make the application play nicely with the rest of the orchestration landscape that we have. So one of the things that is needed is triggers. So a trigger is basically whenever an action happens within AX, you want that particular action to trigger an external workflow or trigger an external application for it to go do something. So the way, so today we do not have an out-of-box trigger support, but it could be implemented using a very few set of codes of line. What we have seen customers do here is they implement their own custom triggers, and it takes, as I said, 3 to 4 lines of code per trigger that they want to add. And they basically use this trigger to send out these messages either to Azure Service Bus or an event hubs, event grids, things of that nature, or even in some cases they directly invoke a third-party web-based API in order to go do certain things, right? The considerations that we need to have when we're writing a trigger is we want to keep that trigger as generic as possible, keep the payload light, so that these triggers could happen as often as possible. We basically do not want to overwhelm the system by creating too many events in the system as well. And also we need to have a way for us to capture a failed trigger. So a trigger is trying to write to a service bus, it's not able to write it, then we should be able to save it into a local table and expose it through a UI so that we can resubmit it or do exception handling. So here is a simple example where Dynamics 365, whenever an operation happens, triggers to an event grid, event hub, service bus, and so on and so forth. I have a simple example where I showcase this. Let me quickly walk you through that code so you can see how easy or difficult it is, right? So the thing that I have done is I have created a separate package within AX and I have named it as sales or a webhook processor. And this is basically the hook that says whenever a sales order gets confirmed, I want a trigger to happen. So that's the first portion that we do. The next thing that we do is within the trigger, we capture the sales order. We capture certain information about it. And I basically I pass that information and send it to C# library. If I look at the C# library, this is the event grid. This is what my event definition looks like. You can go define whatever your event needs to be, depending upon to which output you are exporting to. So this is a simple definition that I'm using for an event grid. So once I am able to pass the sales order into this particular format, I just use something very simple. This is basically the endpoint to which I'm exporting this particular event to. I have hard-coded this over here. This need not be hard-coded. This needs to be written in a configurable manner. Since this is a demo, I'm just hard-coding it, and there's a secret key here using which I export this event. So you can actually see how easy it is to capture an event, although it is a little bit professional developer experience than configurable at this point. So once we have triggers, you can now trigger scenarios in external applications and utilize that. Another pattern that we have seen people ask for, and it comes in many scenarios, is basically having the ability to provide webhooks. So webhooks basically provides you a very clean asynchronous pattern where someone can basically subscribe to one of the events within AX and says, hey, whenever this event happens, notify me in this particular callback URL. And we basically can send that particular information to route that information to that particular application. So if you look at the previous flows that we walked here, you can actually see over here we were doing a polling pattern rather than doing a webhook pattern. Now, if we were to have this webhook, the way we would have returned this is we would have said, here is my package, go download it. Once you're done with it, call me back and let me know that it is done for me to go download, right? So this would basically avoid these unnecessary polling checks that someone makes and reduces the load on AX as well as the middleware. So instead of implementing that entire webhook pattern within Dynamics AX, what we have seen customers do is they have implemented it using an event grid. Event grid is a new component on Azure Integration Services, and event grid provides a mechanism through which someone can subscribe and unsubscribe to an event and also provide a callback URL to the event grid to ask the event grid to call back with the context of that event whenever that event happens. So now utilizing this component, we have simplified the design. AX basically creates the events and sends it to the event grid. It does not manage subscription or unsubscription or notification. That entire aspect of it is handled by the event grid system. So I have a simple demo of it. So I have created a request bin over here. The last request that I sent to this request bin is at 5 hours ago. And if I show you the event grid registration, Okay, it is not on that computer. Most likely it should be here. So while that is loading, let me show you how it actually works, and then I'll show you how I set that up. So basically, I pick up a sales order, and I'm listening to a sales order confirmations. So I'm going to select a sales order over here, and I'm going to click confirm. I'm going to click OK. So now the sales order got confirmed. So behind the scenes, there was a webhook that got triggered. You can see the last message I got here was 5 hours ago. If I refresh it, 14 seconds ago, I got that message. And the message basically provides me a context on which sales order got invoiced, what is that it happened, and things of that nature, right? So this is how I could basically create reactive solutions on the cloud where things happen on AX and then some other application basically reacts behind the scenes. So let me show you how that event grid looks like. So this is the sales order processor with that endpoint that AX was basically writing events to. Here you can actually see that I have done event registration. So this basically is the callback URL. And over here, you can do things like prefix filtering and suffix filtering to say, hey, which sales orders are you interested in, or what type of sales order? You can do some sort of filtering in what you listen to, right? So that's basically how this is done. And once again, all of these could be done in a very dynamic manner. One need not go into a portal to enter these things up. There are APIs that are available that a middleware can call to register itself and deregister itself whenever it doesn't need to listen to something. So coming back to the PPT, so now I'm just going to briefly talk about calling external web applications. So X++ is a .NET first-class language now. So you would be able to call into any of the standard .NET class libraries. And as we all know, the .NET class libraries provides various libraries, .NET libraries to make HTTP-based calls, REST-based calls, as well as SOAP-based calls. And that is basically the approach that you would take in order to make an external web service call. Say, for instance, in fact, this particular demo that I showed where I was making, writing the event to basically write outside is actually AX calling an external web service in a way. As you can see that I'm writing it in C#. You can see that this is a C# project. This is an AX project. And I have that C# project as a reference within my AX project. And over here now I'm free to add any NuGet packages I want, any of the libraries that I want. In this case, it just so happens that I'm good using the net.http library for what I'm trying to do. So another thing that we want to be careful about whenever we are configuring AX to make external web service calls is how we are managing the secrets of the external applications. AX could have scenarios where you might be calling 5 or 6 external web service calls. You may not necessarily want to have all those things lying as clear text secrets within AX. So there are two approaches that we have seen customers utilize. One, we have seen customers utilize the native encrypt decrypt functionality that AX has. If you open any tables, there is a special EDT type. If you set a column with that special EDT type, I think it's called secure string or something, it would basically automatically encrypt that field for us. Anything that you save into it will get encrypted. And when someone reads, they have to decrypt and read before seeing the clear text. So that is one way that we have seen customers secure secrets. The other approach, which is more recommended, is to use an Azure Key Vault. So in the way Azure Key Vault works is you would basically go create a Key Vault in Azure subscription, in your own subscription, and you will provide whatever secrets of the external web applications to which you want AX to talk to. And AX itself will have one client ID and one client secret to basically authenticate itself. Now, at runtime, just in time before it needs access or needs to make a call to an external web service, AX can make a call to Key Vault, authenticate itself saying that, hey, this is the instance of AX which has access to these Key Vault keys, and get the keys at that time and then make the external call. That way, there is two advantages you have. One is the application is completely transparent to whatever certificate changes and key changes that I do in the Key Vault. The other thing is, if something were to go wrong, you would have a good audit log on Keylog that says Key Vault, that says who accessed it, when it was accessed, what time it was accessed, and what keys were accessed. And you can also quickly, with a one click of a button, turn off access or deny access from that point in time until you recover from an attack. Another thing that you want to keep in mind when you're calling an on-premises application is, since AX is a SaaS-based application, any endpoint that AX needs to call has to be publicly addressable, which basically means if you have a line of business applications behind your VPN, you have to expose it one way or other to the public internet. What we have seen customers do is either they have a DMZ zone that they set up through which they expose it. That's a fairly involved process. What we have also seen customers now also uptake is basically set up what is called an Azure Active Directory application proxy. What the application proxy provides is an ability for someone to expose an endpoint using only outbound ports. Even though AX is making an inbound call to call into that endpoint within your VPN, the application proxy and its surrounding components does the magic of converting the inbound request into an outbound request, and they use things like polling to make that happen. And from a simulation point of view, it will look as if AX is making a call inbound, but if you look at the traffic, it only makes outbound calls. There is no incoming calls at all. Another thing to keep in mind is you want any of these secrets and endpoints to be configurable, and don't hard code it into the system when you're making these web service calls. The last thing that I want to touch base upon is basically building a data warehouse integration pipeline. And the way to do it is utilizing the bring your own database feature that is available in the data management framework. So the data management framework provides an ability for you to go create your own Azure SQL database. You can take the connection string and plug it into AX, and you can then choose what subset of entities that you want to sync into this particular database, and you can control at what interval you want that to happen as well. There's also a functionality where you can choose to turn on change tracking, so that when you're doing this recurring push of data, you only do the incremental data that was last pushed from the last time it was pushed. And once you have that data entities in your own SQL Azure database, now from that point onwards, you can either use any of your common ETL tools like SSIS or Azure Data Factory or things of that nature to basically build your enterprise data warehouse. And this is the same approach that you will take for you to enable things like Cortana integrations and things of that nature. So that's the last slide that I have. I know we completed it with 2 minutes to spare. So if you have any questions, I'll take those now. And I'll stick around after the top of the hour to answer anything that is pending as well. Yes, so we do have some internal benchmark numbers for OData integrations. For in the lab scenarios, what we have simulated is around hundreds of thousands, somewhere between 300,000 K sales orders an hour is what we have done using OData. Granted, this was something that was done in a lab environment using our own demo data. What we have enabled is for every implementation to do their own simple benchmarking. And there's performance tools that we have provided that would help you simulate this thing in a fairly quick manner so that you can go with confidence into going live with confidence with whatever performance constraints that you have. And maybe the performance benchmark TechTalk might address how to actually go do that in detail. Okay, the next question. Yes, I'll put all of these code in the GitHub location that we have. So this is the address. This is the URL. I'll do an announcement here. So everyone has access to that. And that is where we have hosted all our sample code. And I'll add all the sample codes that I'm showing today into that as well. So if we go to services sample, if you go to OData console, you'll actually see all the examples that I showed, how to do the chain sets and so on and so forth. Yeah, the same example that I showed. Okay, going back to messages. So Postman is publicly available. If you just type Postman in Google, you should be able to find it. Can we have a link? This was good. Yes, I'll showcase that. If a customer has 10 third-party integrations with OData, how does this impact licensing? Does customer need to buy licenses? Yes, so this is a topic that our licensing team is looking into, and you will hear from the licensing team some announcements on this regard. So yes, there is going to be some licensing about how integrations clients can call into AX and in which band would that fall under. I would let the licensing team answer that, but yes, that is an impact. You have talked about recurring integration that support both files and data packages. Am I correct? I tried to do it, but works only with data package. Could you show me how to export only files and not data packages? Sure, I can upload within a day or two to the GitHub site an example on how to basically do this thing. That is a parameter in the endpoint call that you make, which says whether it is a file or it is a data package, and that's how you basically does the switch. So change tracking works at a data entity level and not on OData level. So OData stack by itself is just a queryable stack. The change tracking that you provide is exposed through the DIXF framework to basically consume it. What do you recommend for native applications where key are removed? So that is a flow if you're doing a native app application. It is, let me give you the link for that. So all of these scenarios are well documented in the Azure Active Directory site. So if you are looking for a native application, they have clear examples on which one to utilize. And there is one that says native application for you to get started. So here is the one where they talk about how to set it up for a native application. Is it okay if I send you the email? Specific issues we have this related to triggers. Sure, please do. Okay, 4 more pending questions. How does on-prem implementation affect integration options available? So instead of the blob storage, we would be using the local file share. Most of the other integration APIs should remain the same. Although there might be some small changes in terms of how parameters would be passed in and read through. But conceptually, if you look at the framework, you should expect to see similar conceptual frameworks being on pure on-premises implementation as well. Yes. So this is purely a middleware thing. So middleware should be doing this translation. I'll cover how to do this on Thursday. There are a number of ways by which we can do it. Since it's going to be a detailed discussion for me to discuss this, I'll cover this in the Thursday session. But yes, we do. The short answer is, if it's like an EDI scenario, we provide mapping, which is either XSLT based, or you can do things like data transform or composition tools and logic apps. Similar things are available in BizTalk as well. Choose file parameter, export creates as a file. Sure. Let me upload an example and let's see if that addresses your concern.
And Praveen, the attendees can't see the questions, so if you could read them aloud before you.
Oh, I see.
Respond.
Oh, I
Sorry.
didn't know.
I probably should have said that earlier, but you were doing it for the most part. Thank you.
Okay. So the question was, how do you? So this one I'll skip. I'll take the other one. For synchronous integration, which one is the best fit? So for synchronous integration, either custom services or OData. OData would be my preferred choice, followed closely by synchronous, by the custom services. Okay, I'll go to the next question. AX article on registering Dynamics 365 on apps suggests to add API access to Microsoft Employee, but in demo, you created only client ID. Yes, I skipped that step. You correctly noted. Yes, you need to go in to the permissions page and provide access to Microsoft Dynamics ERP and the APIs underneath it. That's a permissioning thing that I skipped. On GitHub, there is no test code named data package handler, is it? Yes, there is a test code. It is under a folder called file-based integrations, and you'll find a class called data package handler. Is it OData service good option to use for synchronous integration? Yes, it is a good option to use for synchronous integrations. The next question is, my answer is about integration between Skype and Dynamics 365. Can Skype take the title that it is in the worker table? Can the values be aligned? I have not seen what Skype APIs provide. Maybe this is something that you need to bring up with your solution architect. And if there is a need, we can have an offline discussion, because it's difficult for me to guide you without looking at what Skype APIs provide. But if Skype APIs provide, then yes, you will be able to do that synchronization. Hi, can we have one end-to-end scenario with file and even hooks? Sure, I'll create one. Okay. Do we have any benchmark for OData service usage? Yes, the benchmarks that we have are purely for internal consumption at this point. What we provide is some perf tools and some broad numbers for you to try it out before you go live with your production. Would it be good to use triggers and hit third-party web applications to upload OData? Sure, yes. I mean, the trigger by itself would be pretty lightweight, and the intention is to basically do event programming, but across web-based applications. So it will be a really good fit. Leslie, looks like that's the last of the questions.
Awesome, excellent. Well, thank you very much for answering all those. Attendees can access the web conference recording via the same registration link used to access today's live event. And I'd just like to extend a great big thank you to our presenter. Thank you, Praveen. And thank you, audience, for logging in and joining us today. Have a great day.